So Aiden, if you look at the first quiz and this quiz and the study guide, you'll pretty much have seen everything on the test. In fact, the study guide, I took the test, I pasted it into a new document, called it study guide, added more questions and changed all the numbers. But the take-home quiz also gives you a pretty good idea. Mark your own. Oh, who's my favorite student? Good old Anne. Number 1, how long until the two trains completely pass each other? Oh, got a latecomer coming in here, so I got to interrupt. So, how would I handle this question? First thing is I would identify my strategy. Are there two objects moving at different speeds? This is a job for relative speed. In fact, I'm going to end up using D equals VREL times T, which again, Acacia, I didn't actually put on your formula sheet. Well, I sort of did. It's this in disguise. When A is 0, this whole term vanishes, and when there's two objects moving, we're going to use the relative speed. I said to myself, this is asking me to find time. That must mean they gave me a speed. Oh, I'm going to use the relative speed. If they're heading towards each other, head-on collisions are worse. The relative speed is going to be 10 plus 6. It's going to be 16 meters per second. I need a distance. Well, for these two trains to pass each other, the back of this train has to get all the way past the back of that train. It seems to me the distance is 120 plus the 450 meter gap plus 80. It seems to me the difference is, I can do that in my head, 650, is that correct? I think that's right. 200 plus 450, 650. Now I'm going to get the T by itself. And again, for a question like this, I would also have no problem asking you to solve for D if I gave you VREL and T, or asking you to find VREL if I gave you D and T. Once you get here, it's all good. T is going to be D over relative speed. It's going to be 650 divided by 16. And I get 40.6 seconds. If you got that, I would give you 3 out of 3. Otherwise, I would give you 1 mark if you found the relative speed correctly. I would give you 1 mark if I saw that. I would give you a half mark for getting the T by itself, and a half mark for the answer. Number 2, very similar question, but now the trains are going in the same direction. But again, Scott, I'm going to start out using D equals the relative speed times T. I'm going to make a little note to myself. This wants me to find T. So that must mean I can figure out the relative speed. When we're going in the same direction, rear-end collisions are not as bad as getting head-on, so it's going to be a smaller relative speed. It's going to be 13 minus 5. It's going to be 8 meters per second. And the distance, again, I'm going to argue that to get from there to there is what constitutes passing the train. I'm going to argue that the back train has to travel 150 plus 450 plus 100 meters. I'm going to argue, let's see, what do we have here? 250 plus 450, I think that's 700 meters. And now it's the same question as it was before. I'm going to get the T by itself. It's going to be 700 divided by 8. And I get 87.5. If you got that, 3 out of 3. Otherwise, I would give you 1 mark for finding the relative speed, 1 mark for that, 1 mark for getting the T by itself, and 1 mark for the answer. Now we got into the special relativity stuff. Here I see length, so I need to ask, are they asking me to find L or L0? Well, this 620 is when it was stationary. That must mean that that's L0. Stationary is at rest. So I said, they're asking me to find L. V is 0.96c. What's the equation for L? Is it L0 times the square root, or is it L divided by the square root? I think it's this one, yeah? L equals L0 times that. So it's going to be 620 times the square root of 1 minus 0.96c over c all squared. Do you see? Do you see? Yes, I see. 620 times the square root of 1 minus 0.96. Don't forget the squared. I know that moving objects are shorter, so I should get an answer less than 620. If I don't, I've got my L and my L0 mixed up. Did I get an answer less than 620? So I did this one correct. 173.6. I'll call it, well, you know what? I'll go 173.6 meters. 174, totally fine. 170, I would accept too, for that matter. Will the people on the spaceship notice that? Will they somehow notice that the spaceship is shorter? Why not? How fast is the spaceship traveling relative to them? 0. And so they'll be shorter. Time will be shorter. They won't notice anything. In their reference frame, everything is normal. That's why we don't notice relativity in our everyday lives as well, because we're all in the same reference frame. An asteroid shot past a stationary space station. What length do the people on board the space station measure the asteroid to be? I'm imagining the asteroid is zipping past. I think the space station people will see it shorter. So I think this question is asking me to find L. Oh, by the way, on the previous question, then I would give you 1 mark for the equation, half mark for the numbers, half mark for the answer if you got it wrong. So I think that 45 is again L0. It's the original length. And the speed is 0.98c. So it's going to be L equals L0 times the square root function. It's going to be 45 times 1 minus 0.98c over c all squared. Y'all get 8.95? A rock is accelerated to a speed of 0.99c. What would the mass of the rock be at this speed? Okay. Oh, at this speed? You know what? This is the relativistic mass. They want me to find m. That must mean that m0 is the 65. V is 0.99c. I know masses increase. I'm going to get a bigger answer. It's m equals m0 divided by the square root function. It's going to be 65 divided by 1 minus 0.99c over c all squared. Hey, the c cancels. Oh, wrong button. $461, 460.8. I'll go 461 kilograms. Turn the page. How long is the Enterprise at rest? Ah, this is asking me to find L0. That must be L that they gave me, where V is 0.98c. So how would I get the L0 by itself? I guess L0 is going to be L divided by the square root function. I think. It's going to be 144 divided by the square root of 1 minus 0.98c over c all squared. Do you see? Do you see? What do you see? 144 divided by the square root of 1 minus 0.98 squared. And I got 724 meters. Is that right? Well, I know what you're all thinking. You're asking yourselves, Mr. Dewick, do you mean the Star Trek Enterprise A, the Star Trek Enterprise B, the Enterprise C, or the Enterprise D? That's a good point. This is the Enterprise C from the Next Generation. I looked it up on the Wikipedia page to make sure the numbers were accurate. No Trekkie nerds here? Just me? Okay. A friend borrows your red Ferrari spaceship model X119, capable of traveling at 95% of the speed of light. It's measured to be 5.6 meters high and 18 meters long. You know what? I actually did a bit of a dollop. I drew a little picture. I went, okay, there's the Ferrari. And I guess it's 5.6 meters high and 18 meters long. I said, you know what? If it's zipping by at maximum speed, the 18 is the one that's going to get shorter, not the 5.6. I said, I think L0 is 18. They want me to find L when V is 0.95C. So I said, okay, L is L0 times the square root function. It's going to be 18 times the square root of 1 minus 0.95 C over C. Don't forget the squared. Not divided by, times the square root of 1 minus 0.95. Don't forget the squared. And I got 5.62. If you just said 5.6, that's fine. I said, this is kind of neat, because the height was 5.6 meters. The new length is 5.6. You would see the spacecraft, instead of looking like a long, sleek spacecraft, it would almost be a perfect square, right? It would look square to you. Okay. Your friend has been gone for 5 hours of your time. How much time does he say? You know what? I think this is asking me to find the time on board the spaceship, because my time at rest was 5 when V was 0.95 C. So if I want to find time on board the spaceship, time on board the spaceship is going to be T times the square root function. It's going to be 5 times 1 minus 0.95 C over C, all squared. Were any of you clever enough to notice, or lazy enough to notice, that you can just backspace edit and change the 18 to a 5? Now you got the answer, 1.56. Cool, 1.56 what? Units? This is seconds? This is hours. I'm going to be fussy. You put in 1.5, you put in 5 hours, you'll get hours out. If you said seconds, I would take a half mark off and be fussy on that. It is hours. If it had been 5 seconds, it would be 1.56 seconds. This is what we said about Einstein's equations. They're unit independent. If you put in hours, you'll get out. If you put in days, you'll get out. Put in years, you get out years. Here we put in hours, okay? I had somebody last block say to me, Mr. Dewick, that's 1 hour, 56 minutes, right? Is 1.56 hours the same as 1 hour, 56 minutes? How do you know that can't be right? Remove the sixth. Just pretend it's 1.5 hours. That's an hour and a half. How many minutes is an hour and a half? Is that 1 hour, 50 minutes? No. It's 1 hour, 30 minutes. This is a little more than an hour and a half. If you wanted to convert it to minutes, how would you convert hours to minutes? What's 1 hour? How many minutes? What's 2 hours? How many minutes? What are you doing to the 2 to get 120 mathematically? I think you're multiplying it by what? 2 times 2 is 120? I think not. You're multiplying it by 60. 3 hours is 180. It's 93.67 minutes. Still works for decimals, even multiplied by 60. Anyways, that's a little aside. What's speed? Okay, they want me to find V. I know that mass increases, so the smaller mass is m0. The bigger mass is m. Now, if you got those mixed up, you would get an error on your calculator, and that's usually a hint to say to you, you got them mixed up. So it's going to be v equals c square root of 1 minus, I think it's m0 over m all squared. This question did not say whether it wants the answer as a percentage of c or in meters per second. So for this question, I will have to accept both. On the test, I will be very clear. I was when I typed it up. I will either say give your answer as a percentage of c, or I will say give your answer in meters per second. So you've got to be able to handle both. I'll do as a percentage of c first. To do that, I just leave the c as a c and just evaluate the square root. Square root of 1 minus bracket 2 divided by 4, close bracket squared, close off the square root. 0.866 or 86.6% of C. If you got that, I'll give you 2 out of 2. If you converted it to meters per second, how would I convert this to meters per second? In meters per second, I just multiply 0.866 times 3 times 10 to the 8th. I actually just put the number in there. Although, am I going to type 0.866? What button am I going to use on my calculator instead? My answer button. Times, try that again, Mr. Dewick. Times 3 times 10 to the 8th. And I get, you know, a good place to round off is probably after the 8 because there's a 0 right there. 2.598. Times 10 to the 8th meters per second. I would accept that as well because this question didn't specify. Mr. Dewick, do I have to write it in scientific notation? Could I have written 259807621.1? I guess. Just doing a lot of extra writing. I like number 9, I like number 9, I like number 9, number 9. Well, it's on a quiz, so you already know I like it. It's going to be on your test. A certain star is 40 light years away. That's a distance. How long would it take a spaceship traveling at 0.995 C to reach the star as measured by stationary observers on the Earth? Well, I'm trying to find T. Did they give me a T0 in this question? A time on board the spaceship? So you can't use relativity yet. We're going to use just good old D equals VT and get the T by itself. The distance here is 40 light years. The speed here is 0.995 C. And Aiden, if I plug that in, the C's cancel. I do get an answer in years. They're almost going the speed of light, so as far as we are concerned, they'll get there just shy of 40 years because they're going really fast. 40 divided by 0.995, yeah, 40.2 years as far as we are concerned. As measured on board the spaceship. Now they want me to find T0. Now I'm going to use relativity. I'm going to say, well, T0 is T times that square root function. And T, I'm going to write 40.2, but you know I'm using my answer button there. Times the square root of 1 minus 0.995 C over C all squared. 99.5% of the speed of light is pretty fast. I suspect they're barely going to, the time is going to be way smaller for them. Let's see. Answer button times square root of 1 minus 0.995. Don't forget the squared. And I get 4.015. I'll write 4.02. What's the distance traveled? So there's 2 ways that you can do part C. You can say, I can use good old D equals VT, but this is going to be the distance traveled by the spaceship, so it's going to be T0. How fast is the spaceship going? 99.5% of the speed of light. What's T0? I'm going to write 4.02, but you know I'm using my answer button. and I can go 0.995 times answer button. And so the spaceship, because space is contracting in the direction that they're traveling, that's our explanation for why this is the case, they're only going to travel 3.99 light years. Or you could use the length contraction equation. You could say the original length was 40. 1 minus 0.999, that's messy, Mr. Duke, 0.995 c over c all squared. And if you go 40 times the square root of 1 minus 0.995 squared, you get exactly the same answer, 3.994996871. So you also get 3.99 light years. Either of those is fine. Okay? Oh, for this one, for part marks, I would give you 1 mark for that, half mark for the numbers, half mark for the answer. Here I would give you 1 mark for the equation, half mark for the numbers, half mark for the answer. If you got A wrong, but you put it here and multiplied it by the square root, I would give you 2 out of 2 for part B. And then here I would give you 1 mark for that, half mark for the numbers, half mark for the answer, 1 mark for that, half mark for the numbers, half mark for the answer. Can you give yourself a score on the top of this quiz, please, out of 26? Any lawyering with me? Now is the time.